Class, it's Mr. Z, and today we're going to examine the zero product property and essentially use it to solve equations that were unsolvable. As you can see in number 1, 2, and 3, all of these are in factored form. Essentially, what the person did is they looked at a complex quadratic, they zoomed in, and they went into autopilot mode and they factored it. For number 5, 6, 7, 8, and so on, you're going to see that these are not in factored form. So there is going to be a precursor step to all of these. 4, 5, to get in the sense of what's going on, I need to factor it, and then I'm going to solve, and then I'm going to see what happens in case 1 and case 2. So we're building an extra step. First, we did a little bit of weightlifting and getting an idea of what these solutions, what these answers actually mean. Because, the first unit was like, hey, can I get there halfway? Now we got to become elegant gentlemen and gentle ladies. So let's go ahead and dive in. So for number 5, I would definitely recommend having paper nearby or a whiteboard. And the idea behind this is that 7x squared plus 9x plus 2 is equal to 0. So there's a couple of things immediately I check. Is it in standard form? And the answer is yes, it is in standard form. If it wasn't in standard form, I would have to use inverse operations to make sure that it is equal to 0. I also want to check that A is a positive, and then stuff equal to 0. The second thing I step is it factored. And the answer is, let's see. So I'm going to go ahead and resort to my area model. This is something I use quite often. I'm going to go ahead and plug in 7x squared and 2. And the idea is I have to figure out what factors end up creating a sum of 9x as a result of me picking their spot. So I'm going to go ahead and just 7. The only factors of 7 are 7x and 1x. I also know that the factors of 2 and 1 are only going to be 2 and 1. Now, I'm going to go ahead and use this fact. I need to make 9. What numbers make 9? Well, 7 and 2. So I'm going to go ahead and put the 2 here and the 1 here. To illustrate the option, I could have done it like this. 1x with 2 and 7x and 1. Both of these are legal because they both result in 7x squared and 2. Now I got to see 1 times 1x is 1x. 7x times 2 is 14x. Does 14x plus 1x equal 9x? No. Does 7x plus 2x equal 9x? Absolutely. Therefore, I have an equivalent form of this equation. Notice how this is a step within our problem-solving process. This is going to be a tool we use until the end of time. Get good. So, step 3. I'm going to go ahead and rewrite it in factored form. So, what is it going to be? I look at the left side of my area model. I look at the right side. And I'm going to go ahead and write it out. 1x plus 1 times 7x plus 2, which is going to be equal to 0, is the same as the equation above. So now it is in factored form. This is where I'm going to go ahead and solve for solutions. Remember, think of these as two numbers. Number 1 times a different number. Either this is going to be 0 times something is 0, or it's going to be some number times 0 is equal to 0. This is why this 0 is so important. It is the only number that enables us to do this. I can say 1x plus 1 equals 0. And I can also say 7x plus 2 equals 0. Notice, what is the degree of this original problem? The degree was 2, making it a quadratic. Therefore, I'm going to have 2 solutions. So this is where I go ahead and do autopilot. If I have to show my inverses, I do it. If I can skip steps, I skip steps. But at the end of the day, we should go ahead and get x equals -1. I'm going to go ahead and use inverses again. -2. I get 7x equals -2. And I divide by 7. All right. Notice the levels. Step 1. Just kind of looking at it and making sure, is it ready for me to look at it? Is A positive? Is it equal to 0? Step 2 was, is it factored? Step 3 was breaking up the solution and using the zero product property. Essentially, it enables us, if I have it fixed to 0, it enables me to break it up into 2 separate problems. Now, this is the final part where I previewed in the last video. Are these solutions valid? Case number 1. What happens when x is -1? I'm going to go ahead and plug it in. I have -1 plus 1 times 7 times -1 plus 2 equals 0. I'm going to go ahead and solve. -1 and 1 make 0 times -7 plus 2. I'm going to keep going for posterity's sake. Do we see that 0 times -5 is 0? I want you to see it. What did this answer do? When x is -1, what happens? The solution or the equation is balanced, making it a solution. Case number 2. I'm going to just repeat. Notice how much work is done for one problem. We're getting to that type of math where you see in the movies where they use a whiteboard to solve one problem. We're here. So I'm going to plug in my second one, and this is just going to serve as a review of, hey, how do I confidently handle fractions? So I looked at my factored form, and I'm going to go ahead and write -2/7 plus 1 times 7 times -2/7 plus 2 equals 0. Notice how the color helps make it pop. I substituted in. I replaced my variable with a parentheses. Now I'm going to go ahead and combine some of these guys. I see that I am adding here in this first part. So I need a common denominator. So -2/7 is going to equal, well, a whole is 7/7. Over here, I'm going to represent 7 as 7/1 times -2/7 plus 2. And I know I haven't really done anything, but again, half of math is rewriting it so that it's easier for you to process. On the left, I add the numerators, and I get 5/7. To process this, 7 times -2 is -14. Divided by 7 is -2. A shortcut you might have learned is that because 7 divided by 7 is just going to be 1, I can cross them out, therefore revealing what is negative 2 over 1. Negative 2 plus 2 equals 0. 5/7 times 0 equals 0. Both of these are valid solutions. Notice what happens when x is negative 2/7. The equation becomes balanced, making it a solution. So, again, notice these problems are taking a big chunk of time. You can almost write like a whole paper on each of these. That's how deep these are getting. This has been the discovery. You don't have to be a master of it right now. You should be able to factor it and solve it. And then I need you to start evaluating these just so you can see why these solutions are the answer. Because you're kind of just trusting me. You're like, oh, this is the answer. So continue to play and have fun.